We rarely think of the servers, clients, and networking devices that are necessary in order for us to receive an email, enter information into a blog, or shop for the best bargains online. Most of the commonly used Internet applications rely on complicated interactions between various servers and clients. The key characteristics of client-server systems is that the client sends a request to a server, and the server responds by carrying out a function. The combination of the web browser and web server is perhaps the most commonly used instance of a client-server system. Understanding how these services are delivered allows the network engineer to both secure and troubleshoot a network. Each service available over the network has its own application protocol, or rules, that are implemented in the server and the client software and hardware. HTTP, or Hypertext Transfer Protocol, is the application protocol used for the web. In addition to the application protocol, all the common Internet services use the Internet Protocol, or IP, to address and route messages between source and destination hosts. IP is concerned only with the structure, addressing, and routing of packets. IP does not specify how the delivery or transportation of the packets takes place. For this service, transport protocols specify how to transfer the message between hosts. The two most common transport protocols are Transmission Control Protocol, or TCP, and User Datagram Protocol, UDP. The IP protocol calls upon these transport protocols to enable hosts to communicate and transfer data. In order to help us visualize the interaction between various protocols, it is common to use a layered model. A layered model depicts the operation of the protocols occurring within each layer, as well as the interaction with the layers above and below it. There are two primary models for networking, the OSI, or Open System Interconnect model, and the TCP/IP model. The OSI model has 7 layers and all tasks associated with Internet communications, not just those related to TCP/IP. It is considered the primary reference model for the intercomputer communications. Let's look at how a web page might be delivered over the Internet. First, the application layer data is segmented at the transport layer. Then, the Internet Protocol, IP, which you know from IP addressing, is responsible for taking the formatted segments from TCP, assigning logical addressing, again, the IP address, and encapsulating those segments into packets for routing to the destination host. Finally, the data needs access to the network, and this is where, for example, the most common LAN protocol, Ethernet, comes in. The data link layer prepares the data to be put on the physical medium so that it can travel to the client requesting the web page. On the receiving side, this process is reversed. The requesting machine takes the physical impulses, in this case electrical current, and converts them to ones and zeros and recreates the data link layer frames that were sent from the web server. The data link layer information is stripped away, then the IP information is stripped away, and then the TCP segments are pieced back together in the proper order so the application layer can make the requested web page available to the user. When you think about how often web pages, videos, instant messaging, and other network applications are used every day, the work done by network protocols